right, so number one on the homework, a hockey puck with an initial speed of 8 meters per second. What else we got? Coast 45 meters to a stop across the ice. So coast to a stop. So my final velocity is a 0. And then the distance traveled, 45 meters. If the force of friction on the puck has a magnitude of 0.12 newtons, what is the puck's mass? Okay, so I have force of friction. Right, so, by the way, that's not a lot of force due to friction, right? Because it's on ice, right? So it slides quite a while. Okay, so we're going to use some kinematics here. Since the puck is, in fact, slowing down due to just the friction, and if you're asking why, what about the force that is making the puck move? Remember, the puck has already been hit or whatever it was, right? And so that force has already been applied to it. That's happening prior to this question. Right now, the puck, we become like in media day in terms of the story, and the puck is just slowing down to friction, so that's the only force we have actually operating on the puck. So we can use the kinematic equation. If you guys remember our kinematics, super fun stuff. You guys remember that one? Okay. Excuse you? Now, the reason we're going to use this one is so that we can calculate the acceleration. Okay, so we can calculate the acceleration. So if I'm going to solve for acceleration, first thing I'm going to do is I'm going to get initial velocity over there. Cancel that out. So, and like Andres just mentioned, this final velocity is going to be 0, so I can just get rid of that because it's a 0. So I'm going to have, what do I have? 2a displacement is equal to negative vi squared. And then I'm going to divide both sides by 2 delta x. So that cancels, 2 delta x. And so I end up having acceleration is equal to negative vi squared divided by 2 delta x, which, if I can plug in my values, negative meters per second squared over 2 multiplied by, what's my delta x? 45 meters. And this ends up being negative 0.71 meters per second squared. So this puck is slowing down at a rate, right? Its velocity is decreasing at a rate of 0.71 meters per second squared. Now, that's not the end of the question. We need to actually use Newton's second law to find the mass. Why can we do that? Remember, Newton's second law says that force is equal to mass times acceleration. Well, what's the only force that's acting on the puck right now? Force due to friction. So the force due to friction is equal to whatever mass we're talking about, which is the puck, multiplied by the acceleration of that object, which we just found out. So if I'm being asked to solve for the mass of the puck, I'm going to divide both sides by a. And so this is going to turn into mass is equal to the friction force divided by acceleration, which is 0.12 over, what is that? There, and then my calculator tells me that is 0.17 kg.